Okay, I think we're ready. Let's go ahead and get started today. Um, what we're going to be doing today is talking about something called effective rate. Um, and the idea here is that we want to be able to make comparisons between different types of terms, right? So you can think of them as either saving or loan, but we want to compare different interests. And if it was just an interest rate, then we would have just the one number to compare. But we also have the different compounding periods. Okay, so if we start with like an easy example, if I say, all right, what's a better deal, 6.3% compounded quarterly or 6.3 compounded monthly? Okay, and when I say better deal, we sort of have to be careful about which one we want, right? If I'm saving money, I want the most interest. If I'm borrowing money, I want the least. So, but right now we'll just say, all right, suppose that we're saving money. Well, then if I compound more often, then I'll be getting my interest sooner and more often. And so I'll be getting interest on interest more quickly. Okay? So obviously the compounded monthly would be better. But what if the compounded monthly has a slightly smaller rate? What's better, 6.2% monthly, 6.3% quarterly? Okay. Well, it's a little bit more complicated, right? The monthly is better than quarterly, but the 6.3 is better than the 6.2. So we have to figure out which one wins out here. What's the balance, right? So that's what effective rate is going to be for, right? This effective rate is going to give us a way to compare something like 6.2 monthly versus 6.3 quarterly to see which one is a better deal in our situation. Okay. So the way that we do this, the effective rate is going to be like what would be the percent increase in your money over 1 year. Or another way to think about it is what would be the equivalent simple interest rate that would give me the same amount of money. Okay. So that's what we're looking at. And we have a formula here. Unfortunately, that built-in financial tool in our calculator, it doesn't do effective rate directly. I'll show you how you can use it to do effective rate, but we have to end up subtracting 1 at the end. It doesn't give it to us automatically. Okay. But you'll notice with effective rate, I have less things that I'm talking about. I don't need to know how much I'm borrowing or saving because I'm just comparing the terms, which one's a better interest rate. So I really just need to know the interest rate and how often it's compounded. Okay, so it's less information that we're inputting. Okay, so let's go ahead and skip right to an example and take a look and see what we end up with. So I want to compare a 6.3% interest rate that's quarterly to a 6.2 interest rate that's monthly to see what's better for a savings account. So which one gives me a higher amount of interest after 1 year. Okay, so what we're going to do is we're going to break this up. We'll say, okay, here's my 6.3% quarterly. Okay. And over on the right, we'll look at the 6.2% monthly.
Okay.
So what I want to do is look at the effective rate for each one. So if I plug into the formula, I'm going to have 1 plus 0.063. Since this is quarterly, the n is 4. Okay. So if I type that formula into my calculator, and I'm going to write out all the decimals here, I get 0.0645040645. Okay. Now let's look at the 6.2% monthly. So here my effective rate right? I put in the 0.062 because it's 6.2% interest. It's monthly, so the n is 12.
to the 12.
So here we get 0.0637 317. Okay, so if I look at these, here the 6.3% quarterly is going to be approximately the same as a 6.45% interest, like simple interest. Okay, so here my effective rate is 6.45% if I round to a couple decimal places. Okay, over here it's going to be 6.38% if I round to a couple decimal places. So I can see that the 6.3% quarterly wins out by a tiny bit. Okay. Okay, so that's how we can make comparisons is by doing this effective rate business. Now, what I want to do is also show you how you can use your calculator to get these numbers if you're using that built-in finance app. Okay, so what I do is I hit the app, Finance TVM Solver, and what I'm going to do is I'm going to just treat this as being 1 year. Okay, so if I'm looking at quarterly, right, this would be just 4 times 1 or 4. Okay, my interest rate is 6.3%. And what we're going to do is we're going to imagine that we just start with $1. Okay, and the payments per year is 4. Okay, so then what I end up with is $1 and 6.45 cents. So if I just subtract off the dollar I started with, it sort of gives me what the percentage increase is. Okay. So what I would do if I want to use my calculator to do this is when I look at my final value, I have to ignore or take away a 1 from that final value. And that'll give me my interest, right? I'll get the same 64504 that we had. Okay. And if I look at monthly, we say, okay, this is going to be a 12. It was 6.2. And I changed this one to a 12. Okay. And now here I can see if I ignore the 1, I have my 0.06379, right? So 0.06379, yeah, 0.06379.
Oh, I have $1.
Okay, so the finance app can still get it. It's just not as clean because I have to like subtract a number off, a 1 off. Okay, but otherwise it still works. All right. So let's do another comparison. Let's look at 8.1% interest semi-annually and 8% interest daily to see which one is a better deal.
Semi-annually, every 6 months.
Yeah, semi-annually is every 6 months, which means twice a year. So here the n is going to be equal to 2. For the daily, we'll just always use 365 for the number of days in the year, right? I know that there are leap years sometimes, but we won't worry about that right for this class. 2021 is not a leap year anyway, so here we go. Okay, so here if I look at my effective yield, oops. So we have 1 plus 0.081 over 2, the power of 2 minus 1. When I punch that in, I get 0.08264025. Okay. Or approximately 8.26%. All right, for the daily, right, my N is 365 and the R is 0.08. When I punch those in on my calculator, I get 0.0832775718. Or again, if I convert to a percent, and I'll round to a couple decimal places, we get 8.33%. Okay, so in this case, we see, well, even though 8% is a smaller interest rate, because it's compounded so much more often, I actually end up with a better deal than the higher interest rate that's only compounded twice a year. Okay.
I had a question. What does why are we saying yield?
Well, what I'm looking at, well, we define this as the, I'm sorry, effective rate. You're right. Okay, there's a number of different things that this is called. Effective rate, effective yield, APY, which is the annual percentage yield. You're right. I should have left this as effective rate.
That's okay. It's good to learn a little something now.
Yeah. So effective rate is also sometimes called the APY, or annual percentage yield. Okay. I don't want to get too crazy with terminology in this class. This is, still a math class, not a finance class. So we don't want to get, too crazy with what everything is called. What I want to do though is let you know that there's, a difference. And when you go to a bank and you look at a loan, sometimes the same loan is going to have two different numbers on it. And that's because one of them is the annual interest rate. And then the other one is, well, what is that actually going to get me per year, right? So if I look at this 8% daily, the annual rate is 8%, but it's actually going to net me 8.33% every year because of the compounding. Okay, so the 8% daily is more interest. Okay, now again, when we go through this class, we go through and we learn how to compute things. In your everyday life, people do computations for you, right? When you go to a bank, you don't have to bust out your calculator to figure out this 8.33%. Okay, they'll write that right on there. Okay, what we want to do is understand what it is, right? We want to know, why are there two numbers on the same thing? And this way you can sort of see and get a feel for, oh, this is what that is. The interest rate is 8%, but because of the compounding, my money's actually going to go up by 8.33% after a year. Okay. So that's the idea behind effective rate. All right, any other questions? Okay, well, I don't know if I mentioned it yesterday, but this is a shorty section, and that's it for the week's material. So I think we're good to go. I'm happy to go through and do some homework problems, though. I know that the table gave a few people trouble, so if anyone wants to see that worked out, you can look at how to construct that table from section, I think it was 3 on compound interest. Um,